Okay, so now let's try another problem, which is a trigonometric function. So ito, we have an equation and then we have an interval 0 to 2 pi. So we know that in a graph, 0 to 2 pi lang yung consider natin. Close naman sila, no? Close interval. So at first, we take the first derivative to find the critical point. So we get here negative cosecant squared x and then plus we have cosine of x and then the derivative of the inside, that's negative cosecant squared x, and then um, that will be minus cosine of x, and then we have negative of cotangent of x minus sine of x, and then the derivative of the denominator, which is negative sine of x. And then we divide all of these by the square of the denominator. Okay, so that's it for our derivative. Now this derivative should be equated to 0 and undefined. So before, we didn't have to include undefined kasi nga that's polynomial function. But in this case, since we have a denominator right here and it's trigonometric, so pwede yung ating 0 or undefined. So let's start with 0 first. So if it's 0, then we could just take on cosine squared x to both sides. So that makes this 0 equal to cosine squared x, and then negative cosecant squared x would, I think this would make this negative cotangent squared x, since this is 1 over sine squared x. And then we can cancel this out, and then we're left with the numerator, so we get negative cosecant squared x cosine of x, and then minus cosine squared x, then minus or plus cotangent x sine x, and then there will be positive and then negative, so that's minus sine squared x. So that's it for 0. And then we can also make this, we can also simplify this so further, so we get 0 is equal to negative cotangent squared x. This cosine squared x and then sine squared x is 1, but it's negative, so we can just make it negative 1. So this will be negative cosecant squared x cosine of x minus 1, and then we get plus cotangent x sine x. Now it's a lot easier for us to solve for this when we set all of these equation in terms of cosine and sine. So in that case, I'll be doing that. So in this case, we have here negative sine squared x as the denominator, so I'll be multiplying both of this by sine squared x, just to eliminate all the denominators that we have. So we had 0, and then that's negative cosine squared x. And then for this one, that's this should be 1 over sine squared x again. So we're left with negative cosine of x, and then that will be negative sine squared x. And then for this case, we have this is actually cosine of x over sine x, so we're left with cosine of x, and then we multiply this with sine squared x. Okay, and then we can also add this too, so we have negative 1 minus cosine of x plus cosine of x sine squared x. Okay, and knowing this, from 0 to 2 pi, we can evaluate at the value of pi. So we can also try to have 1 here, so that's 1 is equal to negative, cosine of cosine of x sine squared x, and then minus cosine of x. So if it's 1, and then we can try to factor out cosine from here. So yan, maging ganyan na lang siya. And then what do you think would be the value of x that would make this equation right here equal to cosine of x? And remember, sine squared x minus 1, we can actually have this as something like 1 is equal to cosine of x times negative 1, and then 1 minus sine squared x, which makes this equal to cosine of x times negative cosine of squared x. And then finally we have 1 is equal to negative of cosine cube x. This makes this equal to cosine cube x equal to negative 1, and then therefore x is equal to cosine of x, which is equal to negative 1, and this makes it equal to pi. So that's one of the critical points. X is equal to pi. But how do we find the other one, which will make this undefined? So we copy again the derivative. So this is the derivative, and then we try to equate this to undefined. Oops. So again, this is the derivative, and then we equate this to undefined para makuha natin yung ating other critical points. So this is equal to undefined, something like this, no? And then to make this undefined, we can actually find the value of any portion here that will make it equal to 0, diba? So let's have the same denominator or the LCD for this one. So in this case, I can make it cosine squared x at the denominator, and then we have cosine squared x times cosecant squared x right here. That will make this negative cotangent squared x, and then I'll just copy the numerator, and then I think the numerator is just right here. So this is the equivalent of the numerator. Sorry for being too lazy to write it again. Pero yun lang naman din kasi siya. So, yan na yan. Okay? So, you can also check that kung tama ba, but nagawa na natin yan. So, yan na yan. Okay, and then let's try to simplify further kung meron pa tayo masisimplify. So, I think yun lang yung 1, diba? So, meron tayong negative cotangent squared x and then minus 1. So, yun lang naman siya, and then we have negative cosecant squared x cosine of x, and then plus cotangent of x sine x. Though this cotangent x sine x can also be simplified to simply cosine of x na lang siya. Oops. Equal to undefined. So the value that will make this undefined is, of course, the value that will make this equal to 0. So if it's 0, then that simply means that this is equal to pi over 2, any value that is at the pi over 2, or it could also be any value. So that'll just simply making this cosine squared x equal to 0. So that is simply pi over 2, and then the other one would be somewhere in between pi and then 2 pi. That's 3 pi over 2. So that's it's like the negative y axis for if you translate that into x and y plane or x and y coordinate system. So we have pi over 2 and then 3 pi over 2. So I think there are no other options that we can make this undefined, since for cotangent the denominator is still cosine. Okay, so in that way our critical points are pi. So we have the critical points. So yun lang yung nakuha natin. Bakit? Kasi we're not allowed to use the Rene Descartes rule of sign for this. Kasi nga, hindi naman siya polynomial function. We'll only be using that when we're dealing with polynomial functions. So, iba kasi pag trigo, remember, they are transcendental functions. They exhibit different behavior in graphs and in functions. But the idea here is just too simple, just make it undefined and equate that to 0. Usually, isa lang naman maging sagot natin. Given na meron tayong restrictions, 0 to 2 pi. Okay, but, kung wala tayong restriction, ang dami nating maging sagot dito, hindi tayo matatapos. So, it is very important to take note of this, okay, interval. Anyway, so that's a critical point. And then, let's try to check if they actually would give us the relative or the global maxima or extrema. So we have right here pi over 2, we have pi, and then we have 3 pi over 2. So at the end of this, we have 0, and then we have 2 pi. Okay, so I'll just be using the same concept of just plugging in the values. Don't forget to check on using the radians, and then in this case, I'll be checking any value that is in between 0 pi over 2 pi and then 3 pi over 2, and then you'll be using this the derivative right here. So that's it for the derivative. I'll just copy right here and then try to substitute values. Okay, so for this one, for example, I have f prime of let's say 0 to pi over 2, so let's make it pi over 4, because that's in the middle of 0 and pi over 2. So you can substitute all of these, and then so that will be equal to negative 3.849. Now this method can be simplified using the function in your calculator if you're not familiar with it. So I'll just teach you how it can be done in a simplified way. So there's another option here that you can use, which is the derivative function. So ibig sabihin yan, if you write the original equation, so ito, nagkakamali yung marami dito pagka inalagay nila as yung derivative. So it says here that you need to write the original function, kasi nga ang gagawin niya is differentiate niya yung original function. So I'll be writing 1 over tangent x kasi cotangent yun. So that's just the reciprocal, and then for dito, just write it using the common expression. Okay, so yung tangent to the negative 1 dito, hindi siya cotangent na, that's inverse or arctangent. So okay, malilito dun. And then we have here cosine of x. Okay, so in short, i-differentiate na itong binigay kong equation, and then sasubstitute na itong value somewhere here, and I chose pi over 4. So we have here shifted pi over 4. So in that case, it will give me the value. That's negative 5.414. Okay, so I think mali ata yung na-type ko sa calculator ko, but anyway, so let's just write that. So we have negative 5 negative 5.4142. Okay, and you can also do that in the polynomial function. So it's just that sinulat ko lang yung derivative kasi mas madali siyang isulat kanina. So let's check on, so for this one, we have negative sign. Okay, so negative yung ating sign dito sa ating pagitan ng 0 to 2, so to pi over 2. And then for pi over 2 to pi, we can you can check on that value using since this is pi over 2 and then pi, so kung mapapansin nyo, nasa ano siya, second quadrant na. So in that case, para siyang, you can check on 1 and 1/2, diba? This is 1 and 1/2. So if you take the half of that, 1 and 1/2, you can just use 0.75 pi for that. So that's 0.75. I'll just be using 0.75, and then that's pi. So in that way, mas mataas siya sa pi over 2, but mas malit siya sa pi. So you can do that, at hindi na kayo mas mahirapan. So for f of 0.75 pi, which is in the middle of these two critical points, our answer is actually negative 2.8 negative 2.5858, I think. Okay, so that is negative. So we also have negative right here. And then we have pi and then 3 pi over 2. So for 3 pi over 2, we know that you can select the middle of 3 halves and then 1. So that's basically 1.25 pi. So I'll be using f prime of 1.25 pi for this. So therefore, I can now write right here 1.25 pi, and the answer would be negative. It's the same, negative 2.5858. And with this having the same answer, you can see that there's a symmetry right here. Okay, but that's not our concern. Our concern is at the middle of this, and then the one that's beyond this 3 pi over 2 and then 2 pi. So I'm not using 2 pi right now because it makes the equation undefined right here. So so for 3 pi over 2 and then 2 pi, so we get somewhere, let's just use 1.8. Okay, that's negative 6.76. Okay, so that's just negative. So in short, of all these critical points, pi over 2 pi and 3 pi over 2, we can't see any sign changes. So therefore, we don't have any. We have no global maxima. So do we have actually a negative maximum, or I mean negative? Do we have a global minimum? So we also have no global minimum. Well, simply because if this is negative and this is negative, so basically it doesn't change its direction. So the value is just decreasing and decreasing. So that's just it. And then if we try to graph this function, so automatically we don't have any relative since we don't have any global right here. I mean, there are no sign changes, so wala talaga siya. So we can try to write that. We have pi over 2 right here, and then let's try to have pi muna pala. So we have 0 and then pi over 2. We have pi. And then we have right here, I think it's 3 pi over 2 and then 2 pi. Okay? So with this, you can try to plot out these points, but we know that at pi over 2, we can check on the values muna pala. So at pi over 2, we will use the same concept, no, dun sa original equation natin. So for pi over 2, undefined. Okay, and then for 3 pi over 2, I still think that they will also make this undefined. Okay. So we have, let's try pi. So for pi, that's, I think it's 1. No. So for pi, it's still undefined. So knowing all of these undefined terms, so paano ba natin ito ipa-plot? So with that, we know very well na ito naman mga values na to, and diba special angles sila 0, pi, and even 2 pi. So itong mga angles na to, though critical points sila, they are also points na hindi nagtatouch yung ating values. So asymptotes nila ito, diba? Okay, so basically the graph would be having some asymptotes at that point because they are undefined, and then magi-increase lang sila. So at pi, hindi siya kasama sa solution, so as pi over 2. But for 0, hindi rin siya kasama, so asymptote din tong 0 na to, And to make that, we have somewhere something like this graph. Okay, and then yung behavior naman ito is malalaman nyo siya when you try to substitute values further dito. So kung di nyo siya alam kung paano hanapin yung mga values right here, just provide the table of values para makita nyo yung trend as well. So for this case, ito naman is hindi kasama yung pi, so whole siya, and then it will proceed something like this, and then it will have a symmetry, diba? Kanina nakita natin medyo symmetric sila. So in this case, ayun, magiging symmetric na sila. So that's how it goes for this. And then kung mapapansin nyo, nag-cross sila ng x right here at 0, pero hindi naman sila critical point. So basically, we don't have any value for this. So ang idea is wala naman tayong makikita dito, any global maximum relative minimum. It's just that kung mapapansin nyo, wala rin tayong inflection kasi hindi naman nag-change yung ating curve. So ayun, that's the tricky part in trigonometric equation. Medyo uncertain tayo kung ano ba yung mangyayari sa graph natin. But the good thing about it is that you can always check on the table of values so that you can know the trend. So if you're not familiar with it, you can check on the mode and then go to where's that one? So mode, and then you go to table, and then it says here that about this f of x. So you can type in the equation. So you can write here 1 over tangent and then x, and then plus 1 over tangent x. So instead of you making a table of values, you can actually do that here. It will give you a lot of values. Okay, so in this case, I've already written that, and then you press equal. G of x is another step function, so you just press equal for that, and then start. So you start with 0 because that's our initial value. So you start with 0, and then you end up with let's say 2 pi. And I just wanted to show you the steps. So if the step is just around 0.1, so you can see here that there's an insufficient memory. But if we try to use this, we start with 0 and end with 2 pi, but we step, for example, we step something like 0.3. So still have insufficient memory. So try natin siguro mga, I think mga 0.5 siguro. Hopefully meron na to. Okay, so it's generating values. Okay, so ito, dito nyo makikita yung trend from 0 to 2 pi. So if we start with 0, so may error siya kasi nga asymptote siya doon, so hindi mag-meet yung ating graph. And then at 0.5, so 0.5 is around di ba ang pi over 2 is around 1.7, I think. So 1.4, I don't know, so it's just around right there, but 0.5 is around here, and then that's 3.37, so it's around here. And then kung lalampas na siya nung around this 1.5 bracket, you can see here that pag 1, medyo malapit na siya dun sa 0.273, which is 0, and then pag lumampas pa sa 1.5, which is ayun, naging negative na siya. And then kung mapansin nyo sa 2, which is greater than pi, diba, this is pi, which is, I mean, less than pi, which is, diba, this is 3.14. So you can see here, yung 2 natin is greater than pa rin. So it's around here. Pero dapat, when it's greater than pi but less than 3 pi over 2, so yung pi natin is 3.14. So around 4, I mean 3 point something, dapat siya ay magne-negative na. And look at that, nag-negative na siya. Okay? So that's how it goes for this. And then negative, negative, and then pagpatak niya dito sa portion na meron greater than 3 pi over 2. So 3 pi over 2, yung mga values na greater than doon are around 4.8. So pagpatak doon sa value na yun sa around 4.8, so dapat maging positive na siya. So yan, 5 positive, pero dito diba negative pa rin kasi ito yung portion na yun. So yan, this is one way of checking how the graph looks like, especially when you're trying to just trying to figure it out for yourself. And then, of course, pwede mo rin siyang gawin from 0 to pi over 2 lang, and then make the step point 1 lang, di ba? So, ganun lang siya kasimple when using the table function. Okay, so I think that's all muna for this. And the answer right here is that we don't have any extrema for such case. Okay, so I hope mas naintindihan nyo kung ano ba yung pinagsasabi natin dito sa ating midterm topics na extrema of values. No? So, kung meron kayong mga tanong, just message me, send me some comment, joke, walang ganon. So, you can just email me or message me through Facebook, Messenger, or whatsoever. Basta, kung meron kayong confusions, just raise it, okay? So, I hope mas nag-gets nyo kung paano ba natin nahanap yung critical points, kung kailan siya nagiging global or absolute extrema, kung kailan siya nagiging relative or local extrema, and of course, if meron yung points natin na saddle points, inflection points, and of course, those mga stationary points natin, kung ano ba yung relationship nila dun sa ating mga critical points, okay? And with that, after this, I hope mas mag-gets nyo, mas ma-appreciate nyo kung para saan ba natin ginagamit yung ibang mga rules natin, like René Descartes' rule of sign, Fermat's theorem, yung mga ganong stuff natin, okay? And since this is the only video that I'll be uploading regarding this certain topic, so I hope you can just watch some videos on YouTube kasi marami naman dyan discussion, and it boils down on the same concept of finding these critical points and then just graphing it, okay? And for the next topics, I'll be uploading all about his optimization and application. So, sana mag-review kayo prior to this para hindi kayo nagugulat if ever naman nagugulat. Okay? So, thank you and stay safe, future engineers.